Let's go through an example here. Given that sine theta equals 3/4 and cosine theta is less than 0, find the other 5 trig ratios. Let me just write the other 5 trig ratios down right away just so we make sure we come back to them. That would be cosine, we've got tangent, cotangent, secant, and cosecant. And so we're not going to be done until we write all these out. There's actually several ways to do this problem. You can use trig identities like sine squared plus cosine squared equals 1. You can plug in 3/4 for the angle and square it, and then subtract that from 1 to figure out what cosine squared is, and then take the square root. But probably the easiest way to do this is using the unit circle. So step 1, determine where the known ratio is. I'm just going to draw a quick unit circle. Here's my 4 quadrants, right? And basically, where is sine 3/4? Well, that means it's positive, so that will occur in quadrant 1 or quadrant 2. If cosine is less than 0, it means cosine is negative. Cosine refers to the x-coordinate, so that means I've got to be somewhere over here. Now, step 2, solve the triangle. Okay, I know that the y-coordinate, the height is 3. What I need to do is figure out the x-coordinate. So here we go. I'm going to draw this out. That's a horrible straight line. But if the sine, SOHCAHTOA, I have here at the top, is opposite over hypotenuse, and that's equal to 3/4, then I know the hypotenuse is 4. I can drop this down like this, make a nice right triangle. I know this is 3. And in order to figure out the x-coordinate, I can just use the Pythagorean theorem. X squared plus y squared, 3 squared equals 4 squared. And that means x squared plus 9 equals 16. X squared, subtract 9 from both sides, is 7. X equals plus or minus 7. Aha, 2 solutions. Now you'll notice if it's over on the left side to the left of the y-axis, this has to be the negative square root of 7. Very important thing to remember. Okay, I know where my ratios are. I solved my triangle. Substitute the known sides into the trig ratios. Great, so here's my trig ratios. Be sure to simplify, no radicals in the denominator. So for example, cosine is adjacent over hypotenuse. So that would be negative square root of 7 over 4. That looks simplified. I can write that up here. Negative square root of 7 over 4. Tangent is opposite over adjacent. Opposite, again, here in this example is 3. Adjacent is negative square root of 7. Yikes, that's not good. I've got a radical in the denominator. So I need to cancel that radical out. And I can do that by multiplying 3 over the negative square root of 7 by 1. And if you're wondering, wait a minute, is that 1? Yeah, anything divided by itself is 1, of course, except 0. So when I multiplied this together, notice I didn't include the negative because the negative is going to go up front. Negative 3 square roots of 7 over 7. The radicals cancel out. The remaining ones, we've got cotangent. Well, cotangent is just the reciprocal of tangent, so that's negative square root of 7 over 3. That one looks pretty good. Negative square root of 7 over 3. This one is negative 3 square roots of 7 over 7. Secant, of course, is the reciprocal of cosine. So secant is 4 over negative square root of 7. And again, I can't leave it like that. I've got to get rid of that. So if I multiply both by square root of 7 over square root of 7, I get negative 4 square roots of 7 over 7. Negative 4 square roots of 7 over 7. And last but not least, cosecant is just sine, the reciprocal of sine, and that would just be, well, sine is 3 over 4, so this would make it 4 over 3.